that'll be section 1-2. It's called formulas percent. I had a few examples with formulas I wanted to do, then we'll talk about percents, and that should take us to 615. So a formula is just an equation used to describe a relationship. There's a formula for how cold it is outside, how to convert that to Celsius. There's a formula to find the area of a square, right? So you guys know what formulas are. Now, to solve a formula, let's write this down. Solve a formula. Isolate the desired variable and treat the other as constant. And this is piggybacking off the section we just did. When we're solving equations, we bring the numbers on the other side. When we're talking about formulas, we do that with letters. So take a look at some of these examples. First equation, let's solve G equals RT for R. So the formula, distance is equal to rate times time. If you're going 60 miles an hour for 2 hours, you'll go 120 miles. We want to get R by itself, which means everything else we could just treat as a number. If we want to get R by itself, we have to get rid of the T on that side. So if T were just a number, we divide by it. Divide by what you don't want, you'll get rid of the T. And you just wind up with the rate is equal to distance over time. No different than if the T was a number. Just moving things around. Let's try the formula for perimeter. If I ask you to solve P is equal to 2L plus 2W for L. I want to try to get L by itself. So if we want to get L by itself, generally when we're solving equations, what we do is work from the outside in. So let's start with getting rid of the 2W. First thing we could do is subtract the 2W and bring it on the other side. We wind up with 2L is equal to P minus 2W. We do prefer to have the variables on the left side of the equation. So this is exactly the same thing as just writing P minus 2W is equal to 2L. It's just preferred if you keep the variables on the left. So that doesn't make a difference. Does that confuse anyone or no? No? Okay. All right. And then just to finish it, we want to get L by itself. Let's just divide both sides by 2. And the perfect answer would be L is equal to P minus 2W divided by 2. can get to some more complex equations. So I have a couple that are a little bit more advanced. What about if we had P? So if I asked you to solve P is equal to 2 times L plus W for L. Anyone have any suggestions on how we could do that? It would be the same thing as before, right? Yeah, the easiest thing is, this is a little bit different because the form just looks a little different. We have those parentheses here. What I would recommend for this is I would just distribute it. And then the suggestion was totally correct. It's exactly the same thing. Most of the problems that we're doing in class, they're separated by one step. One step brings you right back to what we just did. So just keep kind of adding one step to these. So again, if we're looking to solve for L, we could subtract the 2W on both sides. So 2L would equal P minus 2W. Dividing by the 2 gives us exactly the same thing. That's the hardest type of problem you'll see in this section. So maybe we'll do one more of those. What if we had y is equal to 1/2 times x plus 3? We want to solve for x. This one I'm going to star off. If you can understand how to do this problem, you'll be good for formula problems. What makes this so tricky is you have a fraction. But we already talked about how to handle that before. Like we said, we just distribute, right? We're going to distribute the 1/2. Y is equal to 1/2 x plus 3 over 2. In my experience, people don't like fractions. So how did we say we can get rid of fractions here? LCD, right? Which would be what? 2, right? So if we multiply everything by the LCD of 2, we don't have to put up with fractions. We can just make them go away. Y equal to 2 times 1 over 2x, 2 times 3 over 2. That one step eliminates all the fractions. Bring this 2 on the outside, this 2 on the outside. You just get 2y is equal to x plus 3. And I did ask you to solve for x. So we could just subtract 3 on both sides. X would equal 2y minus 3. Let's do one more of these. So if we solve 2x plus 7y is equal to 7, and I want to solve it for y. Remember, we start from the outside in. The easiest term to get rid of is what? We want to get y by itself. If we start from the outside, let's get rid of the 2x. All right, very good. Just get 7y is equal to negative 2x plus 7. divide everything by 7, we'll get the y by itself. Y would equal negative 2 over 7x. To finish, we're going to do some applications with this step. So let's use the formula. D is equal to R2, where D equals the distance in miles. R stands for our speed, and T stands for time in hours. And speed is miles per hour. The example looks like this. Say it takes John 30 minutes to drive 21 miles. Time is average rate. So what we're going to do is just use the same formula. D is equal to rate times time, and plug in for what we know. It says 21 miles, so that'll be G. What do we put for time? 0.5. Yeah, 1/2, 0.5. Just remember, when we're using this formula, we need it in hours, right? So 30 minutes. If there is 1 hour is equal to 60 minutes, this just turns into a half hour. So we're just going to multiply by 1/2 of 0.5. And the way that we finish is we just divide both sides by 1/2. Divided by 1/2. Right. Trick question. Not really. It's not the trick question. 21 divided by 2 is 10.5. 21 divided by 1/2 is something different. 42. When you're dividing by 1/2, that's the same thing as multiplying by the reciprocal. And you guys are totally allowed to use calculators in class. If you haven't used fractions in a while, or if you're uncomfortable with them, just use a calculator. I prefer calculators like this. It's just a TI-30X. I have this on the syllabus also. It's on Blackboard. This, I think, was $8 on Amazon or something. This is what I use. This is what I would recommend. If you're joining us from online, it's just a TI-30X. Like $7 on Amazon. I think I have the link on my Blackboard. I'll check later. So that's all I wanted to do as far as distance equals rate times time problem. I do want to finish class up with what's called cent. Means 100. Just like there's 100 cents in a dollar. That word percent, that's where the 100 always comes from. Like 20% is 20 out of 100. So generally, the way that I look at percent is I look at it as part over a whole, or is over of equal to a percent over 100. Generally, all percent problems could be solved like this. So with that said, I have a couple examples here. Let's say a mixture of gas and oil contains 20 ounces, where 1 ounce is oil. What percent of the mixture? What? So you have a bunch of fluid, it's in a container, 20 ounces. 20 ounces. Of those 20 ounces, 1 ounce is oil. What percent of the whole thing is oil? 1 ounce out of 20. The way that we could set this up is just to make this proportion. I'm asking you what percent of the mix is oil? So what percent? We're going to solve for percent here. I'll put an X over there. The trick is we have to be able to put things in the right place, right? So we have 20 ounces and 1 ounce. I'm going to write is over of. What number goes where? Right. You could think about it as is over of. What percent of the mix is oil? 1 ounce of oil. Or even part of a whole. Part of 1. Here we just have to cross multiply to solve the proportion. What I'm going to do is multiply 1 times 100. Set that equal to 20 times x. So this is just 20x is equal to 100. If we divide by 20, we get x is equal to 5. 5 ounces. Or not, yeah, geez. That's what we're looking to solve for. What percent? The answer is 5%. Come at this another way. Let's say a salesperson earns 8% commission on each sold. What is their commission? A $23,000 car. set it up the same way. We have 8% commission. We're trying to find out what do they make from a $23,000 car. So the whole part would be what? 23,000. Under X, yep. What we could do to finish this is just multiply X times 100. 8 times 23,000. That's 8 times 23,000. 18 for 23. If we divide by 100, we get X equals $184. $1,840 is what it would be. Minutes left. I wanted to see if we could get 2 more problems done. And then that'll be it for today. Do we have any questions about what we've been working on with the percent proportions? Is that okay? All right, just finish this up here. The last thing I wanted to finish is percent change. Formula for percent change is new minus old divided by old. And let's do a couple examples here. Let's say rent increased from $1,300 a month to $1,380. Change. All we have to do is just follow the formula. One of those would be considered the new number. Yeah, so we're going to do 1380 minus the old 1300 divided by the old. When we're doing stuff like this, we just do it in little pieces. So first I'm going to do is 1380 minus 1300 is 80. My calculator, it's 80 divided by 1300. Comes out to 0.0615. If you just multiply that by 100, you'll get 6.2% increase. With percent change, you multiply by 100. If it's positive, it's considered an increase. If it's negative, it's considered a decrease. And wanted to finish with one last problem for today. Let's say price of a ticket from $10 to 75. Times the percent change. what would be considered the new price? 75 minus the old. What are we putting it over? Which is what? 110, right? So let's just do one piece at a time. 75 minus 110 is negative 35. Negative 35 divided by 110 is negative 0.318. You get negative 31.8, which is considered a decrease. It went down. That's how you do it.